Hi, let's go over the next homework. So that is homework 4. Okay, so homework 4. And homework 4 was 5.1. And so the problems we're going to go over in 5.1 are 15, 17, 24, and 37. Okay, so let's get started. So number 15 in 5.1. So for number 15, it says assume f is a one-to-one function. For A, it says if f of 6 is 17, f of 6 equals 17, what is f inverse of 17? F inverse of 17 is 6, right? Okay, and for part B, it says if n inverse of 3 is equal to 2, what is f of 2? F of 2 is then equal to 3. Okay, that's number 15. Number 17. Okay, so for number 17, there's a rule on it, so it's a hard. That means it's a hard problem. If h of x is equal to x plus the square root of x, find h inverse of 6. Okay, so the goal is to find h inverse of 6. And so what we want to do is define h of something that equals 6, and then that's something. So if h of something is 6, h inverse of 6 is that something. So I just need to find what value of x would make h of x 6. So let's try h of 4. So h of 4 is equal to 4 plus the square root of 4, which is 4 plus 2, which is 6. And so h of 4 is 6. And so that box thing is 4. H of 4 is 6, so h inverse of 6 is 4. And that's the final answer. Okay. Good. Okay, so that's number 17. Number 24. Good. 24 here. So for number 24, find a formula for the inverse of the function. The function is y equals 2x cubed plus 3. So we'll find the inverse. So that's the function. Let's solve for x. So we have y minus 3 is equal to 2x cubed. Y minus 3 over 2 is equal to x cubed. Y minus 3 over 2 raised to the 1/3 is x. And so now I've solved for x. And now I switch x and y. And so that means y is equal to x minus 3 over 2 to the 1/3. That's f inverse of x. That y is f inverse of x. And now we've solved for f inverse of x in 24. Okay, so there's one more problem. Number 37. Okay, so for number 37, find f inverse prime of a. So we want to find f inverse prime of a. And so f of x is equal to 2x cubed plus 3x squared plus 7x plus 4. And that's 8, and then a equals 4. Okay, so let's find f inverse prime of 4. So f inverse prime of 4 using the inverse function theorem is f inverse prime of 4 is 1 over f prime of f inverse of 4. Okay, so what is f inverse of 4? We need a value of x that would make that equal to 4. Well, the last term is a 4 and everything else is x's in it. So if I plug in 0, then all these terms are 0 and we're just left with 4. So f of 0 is equal to 0 plus 0 plus 0 plus 4, which is 4. F of 0 is 4, right? So since f inverse of 4, that implies f inverse of 4 is 0. And so that's 0. This is 1 over f prime of 0. So just find f prime of x and plug in 0. So f prime of x is equal to the derivative of that, which is 6x squared plus 6x plus 7. And now plug in 0. F prime of 0 is equal to 0 plus 0 plus 7. And that's 7. So f prime of 0 is 7. And so 1 over f prime of 0 is 1 over 7. And so then f inverse prime of 4 is 1 over 7. And that's number 37. Okay? So those are the solutions to those four problems. So let's just do one more. Let's do number 21. Okay, so let's, in addition to that, do number 21. Okay, so we're going to do 21 out of order. So now including number 21, we want to find a formula for the inverse of the function. The function is f of x is equal to 3 minus 2x, so we're going to find the inverse. All right, so y equals 3 minus 2x, solve for x. And so you have y minus 3 is equal to negative 2x. Divide both sides by negative 2. Y minus 3 over negative 2 is equal to x. Switch x and y. Y is equal to x minus 3 over negative 2. That's f inverse of x. Okay, so f inverse of x is y equals x minus 3 over negative 2. Okay, and that's it. Okay, good. And so that is homework 4. We'll do another one. That's in number 18. Okay, so here's number 18. So for number 18, the graph of f is given. A, y is f 1 to 1. So in your textbook, you see that the graph looks like this, where this is y equals 3 here, and this is x equals negative 2. This is x equals 3. This is y equals negative 1. Okay, where this point is happening, and this point is happening. Okay, so in A it says y is f 1 to 1. F is 1 to 1 because it satisfies the horizontal line test. Right? Every horizontal line intersects that graph at most one time. So it's a one-to-one function. For part B, what is the domain range of f inverse? Well, the domain of f is from negative 2 to 3, and the range of f, the set of values of f, is negative 1 to 3. And so the domain and range of f inverse is just flipping it. So the domain of f inverse is the range of f, which is negative 1 comma 3, and the range of f inverse is equal to the domain of f, which is negative 2 comma 3. And so that's the answer, part B. Okay, this is the answer to part A. Okay, and for C of the same problem, so over here I'm going to do part C of the same problem. Part C asks you, what is the value of f inverse of 2? F inverse of 2 is blank, means f of blank is 2. And so what do you plug into the function to get a value of two? Okay, so this point here has a y value of 2. I have to mention that. Okay, so then f of 0 is 2. F of 0 is 2, and so that means f inverse of 2 is 0. Okay, because of that point there. And then D, estimate the value of f inverse of 1. F inverse of 0. F inverse of 0 is approximately what? Means f of what is approximately 0. So what is the approximation of that x value there? I would say maybe, and you have to look at the book for this, I would say it's approximately negative 1.5. It's not trying to scale here. So, well, that's negative 3. Sorry, that's negative 3 in the picture. It doesn't factor into the problem till now. So to draw this better to scale, the picture is kind of like this. Okay, it's still 1 to 1, so it's like, but then here it's kind of like in the middle. So this is like negative 1.5. So f inverse of 0 is approximately negative 1.5 because this is because okay, so because f of negative 1.5 is approximately 0, f inverse of 0 is approximately negative 1.5. I'll stop there. Okay, and so this is an overview of, this is most of homework 4.